are now. Welcome back to the workshop. In today's episode, we're going to strip down this Cooper S engine. So in a video previous to this, we stripped an S block and found a really bad crack running from the center main bolt down along the center main journal and back up again into the bolt hole the far side, and also down into the bore. That block unfortunately is not salvageable. I had a chat with the customer, we talked about it, and very luckily he had another Mini which he thought had an S engine in it as well. It's not a Cooper S, it's a rally car that he's had for many years, and when we had a look with the camera we found that it had an S motor in it. We did a video conference call. When I say had a look with the camera, we did a video conference call and we had a look, and it was a Cooper S engine. He stripped it out, he dropped it down here to me, and I gave him back the other engine. Having a look at this engine, we can see that there is some nuances from Cooper S and there's some other unusual bits on it. So again, probably a bits engine. If we look at this cylinder head, we can see that there has been a lot of work done. We can see these ports here have been opened out quite drastically, in fact. Thankfully, we actually have another S cylinder head casting. I showed it to you maybe a while ago in one of the HRE Uncuts. It was dropped to us as part of the original load of bits the guy dropped me down to build the S engine for his S replica he's building. That cylinder head is perfectly serviceable. We got it magnafluxed and there doesn't seem to be any cracks in it, so it's ideal to get that casting back up and running and use it in this engine build. So this cylinder head will just get taken off and wrapped up and given back to the customer, or else we'll use it on the rally car engine we're going to have to build him to replace this engine out of his rally car. He did tell me that this engine was suffering from low oil pressure, so he said if he drove it on a bit for maybe 10-20 minutes he started to notice oil pressure dropping off. The more he drove it, the more the oil pressure dropped off, unless he stopped it and cooled it down. That's a classic symptom of a bearing failure, so more than likely either big ends, mains, or a combination of the lot is starting to fail. When we look at the engine, we see that this block is very definitely an S casting. It's one of the thin flanged blocks. It has the AEG casting number here, and it has its 1275 S plate here. So we know we have a later S1275 engine block. The gearbox casting number is 22G68, and I'm pretty sure that's an 850, an early 850 Mark I gearbox casting. The 3 synchro type with the bronze balk rings. Well, they're not really balk rings, they're clutch rings, but same idea. So more than likely we won't use that gearbox casing. It also has a hole in the front of it which has been filled up with chemical metal. He did give me another gearbox casing which is one of the later 4 synchro remote gearbox casings that would have been used on these 1275S engines. So I think we will take this gearbox off, but more than likely we won't use it. But it'll be interesting to have a look into that gearbox, because this gearbox has a remote housing on the back of it, a remote diff housing on the back of it, which as far as I know there was never any of those 22G68 cases ever came remote. So this casing obviously has been modified to take remote. It would have been magic wand. Now I'm open to correction, so correct me if I'm wrong in the comment section below, but I'm pretty sure they didn't have that. It definitely has the earlier style drop gear housing, so this will be the small pinion bearing for the transfer gear, and it'll have the bigger transfer gears with that ratio. That'll be interesting to have a look at and see what's in there. First protocol will be to get the clutch, flywheel and drop gear housing off. Okay, with the wok, the clutch, drop gear housing removed. The next thing to do is to get this gearbox off. Then we can get a look into the engine and see what crankshaft is in it, what conrods are in it. Then we can whip the cylinder head off and check and see what pistons are in it and what board the engine's on. And then we can make some conscious decisions about how we're going to move forward with the project. Now, I've always wanted to try this, so now is as good a time as any.
What are you doing?
I'm doing the clicking thing. You click your fingers and the gearbox pops off.
That doesn't happen in real life. I have to edit that in later.
Oh.
Go for it again, and I'll do a cut, and it'll look like it's happened.
See, it does work. Okay, so what have we got in here? With the gearbox off, we can get a bit of a tell as what we're dealing with here. So definitely S rods, AEG 145, which is the S rod. Let's turn this crank over and see is there any markings on it. No markings there, but we have AEG 316 it looks like there. So I'm pretty sure that's S alright. I think that's an EN40B S. I did think they had EN40B marked on them, but I don't see it there or there, but that's not to say it isn't. I've looked in here and I can see the camshaft. There's a number coming up there. How do we turn that around? Okay, so the cam that's in it is AEG 530, so that's definitely a rally sort of race profile. So yeah, we can start to see some of what's going on here. For, you know, looking just straight in here, everything looks good. I don't see any major flaws on the block so far, so that's good. It has the proper fastenings that I would expect for an S, which is those big stud and nut combination as opposed to the bolts, so that's good. As I said, definitely S rods, so that's good. Has straight up primary gears. We will be giving them to the other engine. So I think next thing to do is to get this cylinder head off and see what size pistons we have and what bore we're on. When I'm taking the cylinder head off an engine, I always first start by loosening these rocker posts. The idea behind that is that I can let the cylinder head bolts off then, and the tension will be lifted off the valve springs. If you leave these rocker post nuts on, what will happen is, as you let off the head studs, the pressure of the valve springs will actually lift the head off of the block. Now, there's nothing wrong with that. In the case of here, this is not necessary because we're not going to be reusing the head gasket or anything like that. But if you were trying to maintain a seal inside the engine, letting off these rocker studs first is a better job because it allows you to loosen off the head studs and not lift the head. I personally think it's better as well because you can let off the head studs in an order in such a way to let the rocker shaft come up and not get distorted. I'll show you that now in a minute, how I do that. So just crack all these first, just to get them so that they're turning, and then we can move to the speed brace. So like I said, just let these up a little at a time each, and that's lifting the pressure off of the rocker. If you just let one of these nuts up all the way, you chance bending your rocker shaft. We don't know whether we're going to reuse this rocker shaft or not, but it's still worth protecting it. If you work methodically with stuff like this, you save yourself a lot of hardship down the road. As I've said in my videos previously, I like to use hand tools anytime I'm stripping an engine as much as I possibly can, because it allows me to feel, and I can feel if there's problems, or I can feel if there's a bad thread, and a bad thread or a pulled stud is an indication of a problem that you might need to look deeper for down the road. When you use air guns, they're great, they're quick, they're fast and all the rest of it, but you have no feel, you have no idea. Even the electric nut guns, I'm not even, they work on the same principle, so I'm not big fans of those. Now we'll be able to lift up the rocker shaft. So we can take the rocker shaft out. which is great. I put the rocker shaft down, and then what I do then is I'll put each individual push rod in order with the rocker shaft. Now there's a million different ways you can do this. You know, you can shove them through pieces of cardboard. This is an engine that's going to get completely rebuilt. So the only reason I'm keeping these push rods in order is just if I find a problem, let's say a badly worn cam lobe or something to that effect, I can have a look at that push rod and I'll know which one it was. So it can bring me back up along the way so I can trace a problem. Or, you know, isolate a bad push rod, one that I don't want to keep, or one that I want to get rid of. Okay, next is going to be the Cooper S fasteners. So because this is a genuine Cooper S engine, it has an extra 2 studs. It has this unusual bolt here on the water pump side. People asked me before, why did they use a bolt here and a nut and stud this side? The reason why they used the bolt here was because this hole pretty much always goes through the water jacket into the water pump. If you use a bolt with a bit of sealing agent, you can actually seal to the cylinder head with the bolt. With a nut, you've got 3 paths of leakage. You've got coming out the side of the nut, you've got coming up through the treads, and you've got obviously where the stud goes in. You've only 2 paths of leakage with a bolt like that. So that will be one of the reasons why, I imagine. It uses a very coarse thread actually. It's a UNC thread, 5/16 I think, UNC. So very coarse thread. Now, we will spin off the rest of these nuts, and then we'll be able to lift this cylinder head and get an idea of what we're dealing with, see what's in there. These are the very original type cylinder head nuts, synonymous with the Cooper S's. They're a bigger, heavier nut with a big heavy washer sitting underneath them. There's much better technology now in fasteners than there was then. But for a mild road engine, these would still probably be okay as long as none of them are stretched. People do often ask me, how would I know about if a bolt was stretched or not? Stretched bolts exhibit a symptom. The symptom they exhibit is that when you're trying to wind the nut off, it'll be very stiff and tight. Why will it be that way? Now, here's an example, right? This one is stiff nearly the whole way off. That would be an example of where the thread has pulled, and when the thread pulls, it distorts, and it means that the nut can't spin freely anymore. So that would be an indication that that thread would be pulled. If the nut, after you take it off, see now, there's an example, right? That one is, there's one that isn't pulled. Look, I can literally wind that off with my finger now, all the way up. Whereas that one, I had to wind off with the speed brace. What's that shown me? That's shown me that that stud more than likely has stretched. It has stretched around the threads on the nut. Now, it could also be that the nut itself, the threads have stretched in the nut, so you can test that by winding a separate nut from, you know, a fastener that went easy. So I'll just show you that. There's that nut spinning on that fastener. We knew that was good real easily. But if I put it on the fastener I think is stretched, it locks up almost straight away. And the only way I'd get that to go on now would be to use the speed brace. And I can feel that, that's tight, really quite tight all the way down. So that's indicating to me that that stud is pulled or stretched. As I said, when I rebuild this engine for the customer, I won't be reusing those fasteners because there's just much better quality fasteners available. So, the bypass hose has already been removed. We have those all out. So this cylinder head should lift pretty easily now. And it does. Okay, we'll put that over on the bench. We can have a look at that in a while. Wow, that has had some serious work done to it. The valves are absolutely massive. They're huge. Look at the size of them. And the chambers have all been opened out really wide. Be interesting to see what the inside of that cylinder head looks like. If those valve seats are good, that cylinder head could still be quite good. Okay. this is interesting. This Cooper S has been bored, and it has been bored a lot. You'd guess here if you looked at this first of all that it was on standard size, but it is not on standard size at all. These are a standard piston, alright, but they're not a 1275 standard piston. I imagine these are going to be 73 millimeters or 73.5. They're the Triumph piston, I think. Or they could be something like, they're not Omega. ID25 P05. Let's throw a measure across there and see what size it is. So let's get a rough measurement on these bores and see where we stand. So as I said, this is just a rough measurement with the vernier just to see to the nearest sort of half millimeter. So we've got 73.48. So allowing for a bit of carbon there, they're 73.5 mil pistons, which I'm not sure. It says standard, so there's some sort of an OE piston. As I said, maybe they're Triumph or something like that. Probably could be what it is. They're an OE piston, but they're obviously not OE Mini. They're OE something else. So yeah, they're on that. The bore looks reasonably okay. Now I know the customer wants to make this engine as standard as he possibly can. So I think the road we may end up going with down here is to bring this engine to the machine shop and get liners fitted. I think that's where we'll go. I'm just checking here, I'm just bringing the pistons up to TDC, and all I'm trying to do here is just to see, I just want to see how heavily decked the block is, because I can see the top of the block has been machined. So I just want to see how close to the top of the bore these pistons are actually coming. Okay, there is some room there. That's great, because if these were badly scored, or sorry, if they'd taken too much off the top of this block, it could leave us in a position where we might have to get some unusual pistons to try and deal with what's going on. Just to make sure this is 1275, we'll just check the depth of this stroke. It should be 81.3 if it's 1275. So let's just check that and see. Yeah, we have 81.3. So at least it's standard stroke on 73 mil pistons. So this motor is 1380 cc cubic capacity. What we're going to have to do is I'll have a call with the customer and see what he wants to do. There's more to be done with this engine. The next thing we're going to have to do is we're going to have to strip the bottom end, check the bearings, check the conrods, and check the bores again more thoroughly with some more accurate measuring equipment. Once we do that, we can then make a plan for rebuilding this short motor. I think the plan will be to go with a very mild cam. We might use something like the AC Dodd profile. They seem to be very good. If possible, I think we'll get liners fitted to this to bring it back to standard size, or as near as we can go. I think if we can get liners into it, we can bring it back to standard. So we can bring it back to 1275. The cylinder head, as I said, we're definitely going to go with the cylinder head we have, the Cooper S casting we have, because we don't want, that's a race profile cylinder head and will be absolutely no good for the road. Camshaft wise, the cam that's in it, that AEG 530, I think that's around a 280 duration cam, might even be more. So that would be no good for the road. So we'll give him back that camshaft, and as I said, we'll get him something like one of the AC Dodd profiles. They seem to be performing really very, very well at the moment, and I'm pretty sure he has a couple of profiles up his sleeve that are lovely for road use, nice mild road cam. So I'll get in touch with AC. If you're watching, I'll be in touch with you in the near future. We'll have a chat about a camshaft for this, and then after that then we'll have to spec a gearbox for it. I'm pretty sure we'll go with the other gearbox. Actually, give me a moment and we'll have a look at that gearbox that came off it. So having a look in here at this gearbox, it is, as I thought, a 3 synchro, would have been a Magic Wand box, but it has been modified here to be remote. It's 3 synchro, but they've put a straight cut gear kit. It has a sort of a racy looking straight cut gear kit in here. I'd say originally this would have been the gearbox that would have come with the bronze type synchro hubs, but obviously they've put a straight cut gear kit in here. I don't know if it is, has it got any numbers on it? No, some of these gear kits had numbers on them. I don't know, I think it was an ST thing or something like that. As I said, I'm not 1,000,000% with all my Cooper S stuff, so if people know, but there is no numbers on that shaft. No, or maybe there is actually, hang on. I think there is. I need to get my light, 1 second. Okay, I have my light now and I can have a look at these numbers. Okay, so on the lay shaft is 22G06. That's the number, 22G06. So if anybody knows, let me know in the comments below the provenance of that gear kit. I don't know. I'm not au fait enough with my numbers. So if you do know, let me know in the comment section below. I'd really like to hear. It has a just standard single pin diff. We'll have to take out the crown wheel to measure and see what the ratio is, but looking at the size of that pinion and looking at the size of that crown wheel, I wouldn't be surprised if it's 3.9 or 4.1, because the pinion is quite small and the crown wheel is huge. So I wouldn't be surprised if that's what it is. The casing has had the ever-living life ground out of it. They've been in here grinding out all the casting, no doubt to allow room for the Cooper S con rods to move inside the box, because these were a small bore casting for small bore engines. They didn't have that much room in them. Alrighty, so that's about it for this video, guys. We're in a good position. We have the engine stripped. We know where we stand with it, and we know what we need. We have a few bits and pieces, as I said, to do. So in the next video, what we will do is we will strip the block the rest of the way down. We'll measure the crankshaft, we'll measure the con rods, and we'll very carefully measure and inspect the block. I want to check the block to make sure that there is no cracks or fractures. So far, so good. It all looks good, but I still want to do that. Then I'll chemically clean the block. I'll bring it to the machine shop and I'll get my machinist's opinion as to whether or not he's happy to put liners in this or not. I don't have the facilities here to put liners in a block like this. It takes a very special boring machine to do that, and I just don't have that machinery in my workshop, so I will be outsourcing that. So I'll have to get his opinion whether he's happy to carry out that job or not, and then we can have a chat with the customer and we can make a plan. I hope you guys enjoyed the video. If you're new to the channel, you are most welcome. Thank you for stopping by. I see loads of new subscribers are coming in over the last couple of weeks. I really do welcome everybody to the channel. Thank you for subscribing and thank you for watching. If you haven't subscribed and you're completely new, have a look around and see some of the videos. If there's anything you like and you think we've deserved it, please give us a subscribe. To all my regular watchers, thank you so much for tuning in again this weekend. Don't forget to hit that like button, it does help. Comment in the comment section below. I caught up on pretty much all the comments this weekend, so I'm delighted with myself. I'm going now to do a live with Cole over on his channel. Just literally finished filming this. Poor Billy's going to go edit it and have it up on the channel for you tomorrow. So today will be tomorrow when you see this, and you'll get to see our live with Cole as well. I really do hope you enjoy what you've seen today, and I'll see you guys on the next one.